Welcome to Lecture 10, Trigonometric Integrals. So the overarching goal of this lecture is to learn how to evaluate integrals involving trig functions. So first one we'll look at are functions of this form. So let me just clarify that when I write cosine to the n of x, you probably already know this, but I mean cosine of x raised to the power n. Okay, there will be three cases depending on whether m and n are even or odd or mixed. So to begin, we'll start with the case when m is odd. So now we can write m as 2k plus 1 for some integer k. So doing this, I can rewrite sine mx, make the n a little bigger, equals sine to the 2k plus 1 x, and this is sine squared of x to the k times sine of x. And the reason why I do this is because now I can write sine squared of x. I can use a trig identity, and I can do the always useful sine squared is 1 minus cosine squared of x. It's amazing how much this is used, times sine of x. So it looks like we've made things more complicated, but we've done this because it's going to make u substitution possible. So now our integral that we wish to compute, sine m of x cosine n of x dx, let's just plug in what we've done. So this thing here, so the sine to the m of x becomes 1 minus cosine squared x to the k times sine of x, and now I can't forget my cosine to the n of x dx. Okay, so now I want to do u substitution. So let's let u, I'm going to use red so we can see it, u equal cosine of x. So this means that du over dx is negative sine of x, and so du equals negative sine of x dx. And notice that is what we have right there. Maybe it would be easier if I write this as, how do I want to, let me circle this and let me solve for dx instead. It'll be easier. Dx equals negative du over sine of x. Yeah, that'll be easier because then I'll plug that in right here. Okay, so now our integral becomes, let's make sure I'm doing this okay. So this is, our integral becomes 1 minus u squared to the k times cosine n of x, that's u to the n, times sine of x times dx, which is negative du over sine of x. So now obviously that is going to cancel with that, and I have a negative sign. Let's see if, so this negative sign is going to, let's just pull it out in front of the integral to make things easier. So this is going to be negative integral of 1 minus u to the k times u to the n du. And now, well, we're not done yet, but notice that this thing here this is something we can integrate. This is a right here. This is a polynomial. So we know how to integrate that. It's not. I mean, I'm not going to give you a formula for all k. I think it's the sort of thing that it's easier to do it just on a case-by-case basis. And we'll do an example next. And so once you integrate the polynomial, you just back substitute for u, and then you're done. Okay, so here's our first example. Notice here that m is equal to 3 and n equals 1. So I'm not going to formally let m equal 2k plus 1 and find k. What I want to take from the last slide is that this thing here, what I end up doing is I write sine squared of x times sine of x. So basically, I factor out the largest even power that I can, and then I'm left with just sine of x times cosine of x dx. And now this is the reason why we do that is because now we take the sine squared of x and we write this as 1 minus cosine squared of x times sine x cosine of x dx. And as before, we're going to let u be equal to cosine x. So du equals negative sine of x dx. Or if you want, you can just summarize this by, I guess the second step by saying dx equals negative du over sine of x. And that's what we're going to plug in for our dx. Okay, so let's plug this back in. So this is the integral of 1 minus u squared. And now cosine of x becomes u. And let's do a sine of x here. So I guess I've reversed the order, but so this becomes that, this becomes that. And now my dx becomes negative du over sine of x. So I can pull out the negatives. So of course these two things are going to cancel. So I can pull out the negative sign and I can write this as 1 minus u squared times u times du. So let me just multiply this out to be safe. So this is, pull the negative sign in now as well. So this is positive u cubed minus u. Is that right? Add du. So this is u to the 4th over 4 minus u squared over 2 plus c. And now let me back substitute. U was, what was u? U was cosine, so this is cosine the 4th of x over 4 minus cosine squared of x over 2 plus c. And there is our answer. Okay, good. Next, case 2. M is even and n is odd. So the last one, I didn't care what n was. I just said if m is odd, that's how this works. Here, so maybe I could have called this case 2a, where m is even and n is odd. Case 2b will be when both of them are even. Okay, so in this case, let's see. So we are going to let n equal to 2k plus 1. So in both the two, I guess in either case, if we're going to take the odd one and write it as 2k plus 1. Okay, so now let's rewrite this integral. So we are going to write sine of mx, that should be an m, cosine of nx dx. So as before, I'm going, well, I'll just write out every step. So sine of mx times cosine of 2kx times cosine of x dx. And the reason why we're doing this is because we want to, now we're going to use a trig identity and write cosine squared as 1 minus sine squared. Okay, so let's write that as equal to sine mx. Make sure you know that's an exponent. You should, but times. So this is 1 minus sine of x 1 minus sine squared of x to the k times cosine of x dx. So now we're going to let u be equal, to sine of x. So what we want to do, as in the previous one, we don't want to touch, this is going to be part of our du, so this is the thing that we want to simplify. So we let u be equal to sine of x. That of course means that du over dx is cosine of x. So we want to substitute for that. Dx equals du over cosine of x. Okay, so let's make these substitutions. So this integral is equal to the u to the m. Now we have 1 minus u squared to the k, and we have cosine of x, and we have du over cosine of x. And this is going to simplify to u to the m, 1 minus u squared to the k du. And this is now something we know how to integrate. It's a polynomial, and then we can back substitute. Should you memorize this formula? Heck no, I don't have it memorized. I just know how to do it. Just if you can follow this process, it's much easier than memorizing where the negative sign is, what's m and what's k. Okay, here's an example. Evaluate the integral of cosine cubed of x dx. Now upon first glance, this may not look to be the same form as what we just did, but it is, because m can be taken to be 0 and n equals 3. So if we do this integral, well, let's do the same thing we did before. We always want to pull out the largest even power of cosine. So when we get something like this, and the reason we do that is because we want to turn that cosine squared into a 1 minus sine squared of x, cosine of x dx. So now we can do u substitution. We let u equal sine of x, du over dx equals cosine of x. So our dx that we want, yeah, that's right, is du over cosine of x. So now we're turning to this integral. This is the integral of 1 minus u squared times cosine of x times du over cosine of x. So the cosine of x is cancel, and this thing simplifies to the integral of 1 minus u squared times du. And this is something we can do rather easily. This is just u minus u cubed over 3 plus c. So if we back substitute, that is sine of x minus sine cubed of x over 3 plus c. And that is our answer. Okay, so the last case is when both m and n are even. So we're going to use a similar strategy here. We are going to let m be equal to 2k and n be equal to 2l. So as before, we're going to try to group power. We're going to write this as powers of sine squared and cosine squared, and then use identities. So now this integral of sine to the m x cosine to the n x dx. This is, let's see, this is going to be equal to integral of sine squared x to the k times the integral of cosine squared x to the l dx. And now we're going to use a new identity. You've seen it before, just one we haven't used in this chapter. I'm going to, well, let me show you first. I'm going to write this as the integral of 1 minus cosine of 2x over 2 to the k, and this, remember, is equal to sine squared of x times 1 plus cosine of 2x squared to the l dx, and this second term is equal to cosine squared of x. This is one of those ones that you should have memorized. There's not too many that I ask you to learn, but this is one of them. So of course, we've turned this product into this product right here. So why does that help? I mean, it doesn't look like we've done much, but now we can actually multiply this thing out, and when we do this, we're going to be in the same, well, we're going to be in the same case we are here. So let me just say this. So now multiply out, and when you do this, you're going to get, let's see, what we're going to get an integral of let's see, it's a bunch of powers of cosine to the 2x. So we're going to get, I don't know, we're going to get like a plus b cosine 2x plus c times cosine squared of the 2x plus d cosine cubed to the 2x. That's supposed to be cosine. Let me make that better. And then so forth. So for each one of these terms, well, for those two you know how to deal with it. For all of the odd power terms, you know how to deal with that, the previous cases, and then the ones you don't have, the even powered ones, well, now you are back to this case again, but you have a lower power of cosine, because here the maximum power you can have, you've cut these exponents are half of what you started with. So at some point this process is going to terminate. So for example, in this case, that thing here you would write as 1, let's be careful, 1 plus cosine of 4x over 2. And then you could, there would be no trouble integrating that. So let's do an example. So let's do an example, and actually before I start, I'm going to make this example just a little bit harder, because I think you'll learn more if it's more complicated. So I'm going to make that a 4. So now, the first thing to do, as we always do here, is we break this into powers of sine squared and cosine squared. So this is sine squared of x squared times cosine squared of x dx. And now we use our trig identities. So I'm going to write this as the integral of 1 minus cosine of 2x over 2, that should be an x, come on, squared, times 1 plus cosine of 2x over 2 dx. Now I'm going to pull out this 2 and this 2. So, well, this 2 is squared, so I'm pulling out a 4 times 2. So I'm going to pull out an 8. So I'm going to write this as 1/8 the integral of 1 minus cosine of 2x squared times 1 plus cosine of 2x dx. Okay, so let's simplify this a little bit. This is 1/8 times the integral of, well, what's the best way to do this? Okay, so this is just algebra. I'm going to write this as a difference of, so watch what I do here. It's easy to multiply a difference of squares. So I'm going to multiply 1 minus cosine 2x times 1 minus cosine 2x, 1 plus cosine 2x. So if I do that, this is going to be, so I have 1 minus cosine of 2x, it's supposed to be an x, and then 1 squared minus cosine squared of 2x dx. And so to simplify this, this is 1/8 times the integral, so let's do it by powers. The lowest power is 1. The next lowest power, let's see, there's cosine of 2x, so there's negative, so 1 times negative cosine 2x, so that's a negative 1 cosine 2x, and then is that the only contribution? Let me just check. It looks like it is. Yeah, so this is going to be a negative, oh, let's switch back to a pen, 1 minus cosine of 2x, and then how many cosine squareds do I have? I have a minus cosine squared 2x, and then I have a plus cosine cubed 2x dx. So now this is something that's easy to evaluate. This integral we can do. This integral we did in the previous example. And this integral we can do using the same technique. It's simpler. Okay, so I'm going to separate these by difficulty. So this first one, well, let's see, I can do this right away. So let me just pull out and do that. So this is going to be the integral of, so this is going to just, this first part is just going to be 1/8 or 1/8 x, this, and this second part is going to be, so let's see if I can do this in my head. So it's the integral of negative cosine is going to be negative sine, but I'm going to have to divide by 2. So this here is going to be, it's going to be minus 1, let's get the pen again, minus 1/16 sine of 2x. So right now I've taken care of both these terms right here. So what's left is 2, so minus 1/8 integral of cosine squared of 2x, and then plus 1/8 times the integral of cosine cubed, cosine cubed 2x dx. So this thing here we can do using the same technique as up here, using this half angle formula, and this thing here we did in the previous example, so we know how to do that. Let me just let me be really, it's easy to make a mistake here. Let me write this, let me do a u substitution here. So here I want to let u be equal to, well, hold on a second. What do I want to let u be equal to? Do you remember? So this thing, this whole integral, I want to write as cosine squared of, what do we want? Oh, I know. Yeah, u, I actually want to, let u be equal to 2x. So I'm not going to actually do this integral. I'm just going to use the formula that we had before. But right now, the formula involves x and not 2x. So u is going to be equal to 2x. So du dx is equal to 2. So dx equals du over 2. So this integral is really going to be cosine cubed, let me make that cosine cubed, times u over times du over 2. So that's what that integral is. So, okay, so let me rewrite this last line. Okay, so I'm going to leave these first two terms alone. 1/8 x minus 1/16 sine of 2x minus 1/8 times the integral, and now here is where I'm going to use this technique that we just learned about. I'm going to use this substitution, but I got to be careful. I have a 2x, so by my double angle formula, this is going to have to be 1 minus cosine of 2 times 2x, or 4x over 2 dx. And now this last one is going to be plus, let's see, now I have I have to be careful here. So I have this dx is going to be du over 2. So this is going to become 1/16 times times the integral of cosine cubed u du. Okay, so now I have 1/8 x minus 1/16 sine of 2x. Let's be careful here. I have the integral of, or negative 1/8 times 1/2. So that's going to be minus 1/16 x. Now the second term here, I'm integrating, so let's see, minus negative, so that's going to be plus positive. I'm integrating 1/8 times 1/2, 1/16 cosine of 4x. So when I integrate cosine of 4x, I'm going to have to divide by 4. So I'm going to get 1/16 divided by 4, and I'm going to get, that's going to be 1/64 sine of 4x. And I believe because this is minus negative and the integral of cosine is sine, that's going to be a positive. Is that going to be a positive or a negative? Hold on. I did something wrong here. This has to be a plus because that is a plus. So that's going to make this a negative 1/64 sine 4x. Okay. So that term is done. And now I have 1/16 times, using our formula using our result from the last problem, sine of u minus sine cubed of u over 3 plus c. So I'll just stick the plus c at the end. And now I think I can simplify all of this in just the next line. So let's see. I have a 1/8 x and a minus 1/16 x. That simplifies to 1/16 x. Okay, now how many? Look at the. Oh, let's mark this off first. I've used both of these. Look at this. This term here, negative 1/16 sine 2x, is going to cancel with this positive 1/16 sine 2x. So those terms are going to cancel. Now I have a negative 1/64 sine 4x. That's right there. I also have over here, I have a negative 1/48 sine cubed of u, which is really 2x, and of course I have my c, and there is my answer. It's a little bit longer than I thought it might be, but I think it was instructive. Okay, so the last part in this section, and now there's a lot more things to do with integrals involving trig functions. And you can look at the book for a bunch more random examples, not random, but more obscure examples. But the last one we're going to do is how to get rid of a square root, something like this. So we don't have a formula for integrating, root 1 minus cosine 4x, but what should you notice about this is that look what's underneath the square root. 1 minus cosine 4x. Does that look familiar? Well, if you use, so 1 minus cosine of 2x over 2, this thing, of course, is equal to sine squared of x. So that's not quite what we have. So what we have is we have 1 minus cosine of 4x over 2 equals sine squared of 2x. And of course I can multiply, let me put a 2 here and then let me cancel that 2 there. So if we do this, we can rewrite this integral as integral from 0 to pi over 2 of the square root of 2 sine squared of 2x dx. And I always like factoring out constants, so I'll factor out the root 2, write this as 0 pi over 2, sine squared, and then take the square root. That is the absolute value of sine of 2x dx. And let me see, sine of 2x, what does that look like on the, so that's going to look like this, and this is going to be pi, and this is going to be pi over 2. Okay, so fortunately on this region this is positive, so the absolute value we can just ignore it. So this is root 2, integral from 0 to pi over 2 sine of 2x dx. So this is root 2 over 2 cosine of 2x. Now I always have to see, is this positive or negative? That should be negative, so let me put the negative out there. 0 to pi over 2. So, so we can evaluate this. So this is, let's see, so we could have done this u substitution, if we wanted to. We could have let u be equal to this, but we don't need to because we know how to integrate this. So this is equal to root 2 over negative root 2 over 2 times cosine of pi minus cosine of 0. And now remember what cosine is equal to. Draw the unit circle. This is 0 radians and this is pi. So cosine of 0 equals 1, because that's the x coordinate, and cosine of pi equals negative 1. I always draw these pictures. I don't have them memorized. So this is equal to negative root 2 over 2 times negative 1 minus 1. That's a lot of negative signs there. So let's, this thing, we can bring this negative sign in, and we can just make this plus, 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 and this becomes a 2. That cancels with this 2, and our final answer is root 2, and that is that.